Gorell and his colleagues conducted a study on asocial red squirrels over a period of 19 years to determine the occurrences of adoption within the species according to Hamilton's rule, AB is greater than C, as stated by Gorell et al. Adoptions were confined exclusively to the circumstances in which the benefits to the adopted juvenile, discounted by the degree of relatedness between the surrogate and the orphan, exceeded the fitness costs of adding an extra juvenile to our litter, as predicted by Hamilton's rule for the evolution of altruism. By using an asocial species, a species that avoids social interaction, Gorell clearly demonstrated Hamilton's rule in the study. When juvenile red squirrels were in need of adopting, they were only adopted by closely related kin rather than an unrelated female who could benefit more. Over the 19 years, there were 34 cases where a mother squirrel died and juveniles were left behind. Out of these, 5 were adopted by kin, and a further 2 groups of litters could have been adopted by kin but were rejected. These 2 anomalies are also shown in Table 1, labelled as NA1 and NA2. Out of the adoptive females, A1 and A3's litters had died and were greatly able to adopt a juvenile. A2 and A4 had 2 juveniles in their own litter, and A5, who also adopted an orphan juvenile, had 4 in her original litter. In the remaining 27 cases, there were no kin available to adopt the orphans. The graph shows the results of the 5 adoptions. Females A1, A2, and A4 had the same amount of relatedness, whereas female A5 had a higher maternal relatedness and genetic similarity. The solid black dots represent the litter size of the females that adopted an orphan, and the white dots represent the 2 related females who did not adopt an orphan. Hamilton's rule states that RB is greater than C. Adoptions would occur when the fitness of the juvenile outweighed the cost to the surrogate. The resulting graph showing the adoptions describes that when an adoption occurs, the fitness of the natal litter decreases. The fitness of the orphan juvenile decreases as the natal litter size increases. However, in all 5 cases of adoption, inclusive fitness increased, especially when the adopted juvenile was closely related. If adopting a related juvenile would reduce inclusive fitness, adoption did not occur. Unrelated juveniles were never adopted. It would be recommended that to further prove Hamilton's rule, this sort of testing should be done on a range of asocial animals within the same parameters.